Hello and welcome back to Cracking the Cryptic, and look at this fabulous image on the screen. This is from the puzzle we're going to have a go at today. Not quite in the form we're going to have a go at it, but this is Malrog's original art for Spiral Galaxy, and I think it looks fantastic. We'll get to the puzzle in a minute. First of all, do remember that on Patreon we have, of course, our regular Sudoku hunts. There's always a competition up till the 20th of the month and other stuff going on there, like Quinn Lux's hunt, all sorts of things. It's well worth having a look into Patreon and possibly considering the $2 or $3 a month that it requires to join it. And we appreciate any support we get. Also, of course, you can check out our apps on the links under the video, and Sven's SUDOKU PAD and everything going on around the channel. It's all mentioned in the description field. But it is great to get a chance to do a puzzle by Malrog. I did a puzzle by him before, and having speculated about whether his name was connected with the Balrog from Tolkien's Lord of the Rings, I then very foolishly wrote the name Balrog instead of Malrog on the card for the video. So sincere apologies to Malrog, who is definitely Malrog and not Balrog, and today we will get that right. Now, this puzzle looks fabulous, as I say, but let's go to the image that we're going to use to do the rules. So here we go. This is Spiral Galaxy by Malrog. Now, normal Sudoku rules apply. Digits along the marked diagonal, that's the blue line, must not repeat. Digits along grey lines increase starting from the bulb end. So these are thermos running there and running symmetrically the other way. So they're very prettily drawn. Coloured lines are palindromes reading the same forwards or backwards. So that cell will be the same as that one where the palindrome ends. That one will be the same as that one, etc. Digits along an arrow sum to the number in the circled cell. So those two add up to that. Those two add up to that, and those two add up to that. Now, this is fascinating. To me, this doesn't look like enough information to be a puzzle. You've got two thermos, two palindromes, neither of them excessively long. The diagonal, that sometimes has a bit more effect, but then three tiny arrows, I don't know. It's fascinating to me that this works. It's a lovely idea for a puzzle, whatever. It really did look like a spiral galaxy, both in the original and indeed in this version, and I'm fascinated. Give it a try if you like on the link under the video. I'm going to start now, so let's get cracking. And I say that in full knowledge that I'm not going to have a clue where we get cracking. Okay, here's what a Goodlift does. He marks up the palindrome. The thermo. So this is a 1, 2, 3, 4, 5, 6, 7 cell thermo. Both of them are 7 cell thermos. Okay, what I'm going to do is mark the full 2 degrees of freedom in each cell. And I think then, okay, we see something immediately there. But I'm going to carry on doing that. I didn't expect that. I should have done, but I didn't. What I did expect was, I don't think this could have been a 3. Okay, well, I was going to say this couldn't be a 3, but it's all much better than that. Because look, we've got a 2, 3, 4, 5 quadruple in box 5 immediately. Those 4 cells, because of the maxima and minima on the thermos, have to be 2, 3, 4, and 5 between them. Therefore, this has to be a 1. And we have a start in the middle. That's very much Big Bang Theory, I think, if you get a 1 in this center of the galaxy. And you physicists will know that I don't know what I'm talking about. Right, the remaining cells in the central box are 6, 7, 8, and 9. And some of these are on the palindrome. Oh, annoyingly, that one is the middle of the palindrome. Because the palindrome, like the thermo, is 7 cells long. So that's the middle, which is not a relevant cell in the palindrome because it doesn't map to anything. But that one maps to that, and maybe we'll be colouring them. That one maps to that. And that didn't give me as much on the palindrome as I was hoping. Now what? Right. Okay, 2 is confined to one of those cells in the central box. They're the only cells with a 2 candidate. And 5 is confined to these two. Now, one of those must be a 5, obviously. So therefore, one of these must be a 6. Yeah, okay. Whichever one is a 6, and it might be both, but I'm not sure about that. But whichever one of these, at least one of them is a 6. Whichever one is a 6, the rest of the thermo is going to go 7, 8, 9. And that means on the other thermo, you can't have an 8 here. Yes, that's right. Say this was the 6. This would have to be 8. Now this couldn't be 8, and that means this couldn't be 6. So in fact, only one of those two is 6. But one of them is. Now does that apply to these as well? Does one of these have to be 7? Yes, this does apply to these. These can't both be 8, so one of them's smaller. In the case where one of these two is smaller than 8, this one won't be 7. So one of these two won't be 7, but the other one will be, because it will come after a 6 on the thermo. That means that this is a pair of 7s, and they both see this cell. So no, it's not a pair of 7s. It means one of them at least is a 7. Oh, I put that in the wrong place. Sorry, 7, 8, 9 there. One of these at least is a 7, and that means these two cells can't have a 7 in. Which probably doesn't do a lot. These two can't be the same. That's another reason they couldn't both have had a 7 in. Okay, this is because these are the 6, 7, 8, 9 in the central box. If these two were the same, or these two, whatever digit that was the same in both of them, couldn't be placed anywhere in the central box. So these two are different. These two are obviously different because they're in the same column. One of them is an 8 because one of these is a 6. These two are different. But is 5 still possible? I don't know. I don't know really how we progress at all, but I'm just trying to understand what we've got here. One of them is a 7 and one of them is not. Gosh, I don't know what else we're meant to be doing. Right, let's have a think. Okay, maybe, I don't know, about these two cells, which are they're not the same. Oh no, of course this is 1 on a palindrome, so these are both 1s. What am I talking about? The orange palindrome and the purple palindrome have a 1 at the ends, ever since we got that. I just haven't marked it. Right, so these two are the same. Now that's interesting. They can't be low, I've just worked out, and that is because if these two were the same, then whatever digit was in them, well, sorry, if these two were low, they are the same because of the palindrome. If they were low, whatever digit was in them couldn't appear in these cells. And 2, 3, 4, and 5 have to appear in those, so these can't be from 2, 3, 4, or 5, they're from 6, 7, 8, or 9. I reckon the same happens here. Yeah, they're seeing this plus shape in the middle as well. So now I've got a 6, 7, 8, 9 quad in the central column. I wonder if I've got anything else. Not much, but in one of these instances of these T's, we have a 6 in the first thermo cell. So then that must be a 6, 7, 8, 9 quad for that one. One of these in the column is going to be a 9, because they're the only places for 9 in the column. Whichever one is a 9 is not the place where 9 is on the palindrome, it's on the thermo tip here. So whichever one is a 9 gets an 8 there, a lower number here and a lower number here, but whichever one isn't a 9 has 9, 8, 7 going on there. So whichever one isn't a 9 is a 6, because one of these thermos ends 7, 8, 9. So one of these two cells is a 6, and we know one of them's a 9. So that's a 6, 9 pair. This now can't have a 6 in it as a result of the 6-9 pair in the column. So that's 7 or 8. Which was likely anyway. I have a feeling these are going to be 6 and 7, but I'm not sure I can prove it yet. Oh, what an interesting puzzle. Don't know what to do with the 2s, 3s, 4s and 5s. Right, okay, let's think then, because the 9s, one of them's in the tip and one of them's in that position. Oh, and this has become 6 and 9 and that's become 6 and 9, so we can match those on the palindromes. Mustn't forget to copy the palindromes. Now we have a 6-9 pair in the row. Anyway, one of these, there is a 9 in one of those two cells and a 9 in one of those, because one of these is a 9 and one of those is a 9. So it's a sort of weird skewed X-wing. Now, one of these is a 7. And it's in the same box as the 9. So somewhere we have, yeah, we have 7, 8, 9, 6 going on. So 8, 6 in one of these pairs. The other pair then must have 9, 7 in it. So this will be an 8. It doesn't tell me whether that's a 6 or a 5, and I still don't know which one of them I'm talking about. Oh, this is a weird puzzle. Right. What on earth? Okay. One of these is a 6. That must go with a 9 here. Now, I don't know what this means for me. I keep looking at this arrow and wondering, do I know anything about it? I mean, I know that this is a 5, 6, 7, 8 or 9. Ah, actually, I've got better... Oh, no, I haven't. Oh, yes, where does 1 go in this box? That's quite an interesting question. 1 can't be there or there because of these two 1s. And because of the diagonal, it can't be there or there. So 1 must be on this arrow. So there are consecutive digits on the other cell of that arrow and in the circle. Could still be a 5 with a 1, 4 there and a 2, 3 there. Actually, yeah, it could. You could, yeah, those would be from 6, 7, 8, 9. And that would be 5. And I think that works at the moment. 4, 3, 2. Oh, crikey. What do we do next? Oh, there's a 2 in one of those cells, so those can't have a 2 in. That's not really interesting, but nonetheless, it's fact. One of these two that I've got highlighted has a 5 in. No, that's not interesting. I was going to say there's a 5 in one of these, but I don't know that. That could be a 7, 6 pair. In fact, that's probably a bit more likely. Right, come on, think of something interesting. Okay, 1 down here is in one of these cells, and not the circle, obviously. That's not very exciting news. How am I going to tell these apart? Surely, I mean, this puzzle is so symmetrical that I can only disambiguate which of these thermos is which by reference to these arrows. But I don't know by what reference to these arrows at all. Gosh, what are we meant to do here? Okay, if 8, one of these is an 8, and one of these is an 8. So that's accounting for 8 in those boxes. So we've accounted for 9 and 8 within those 3 cells and the equivalent 3. Oh, and 7. 7 must be confined to these cells because we know one of these is a 7 and we know one of these is a 7. So what? So what indeed? Am I missing something on the palindromes? Okay, let's colour, because I haven't done that. And I did think about it. Right, that is the same as that. Now, then it can't be this cell. I don't think it really is telling me much else, though. That's the trouble. Is it really about this? I haven't thought much about the diagonal, I suppose, but I don't know what I can think about the diagonal. I don't know what there is to consider about the diagonal. Where do we get started on it? Where does 1 go on the diagonal? Oh, we've got 1 on the diagonal and right in the centre of the galaxy. Okay, that colouring didn't go very far. I don't know what to do. This is such a strange puzzle. I haven't missed any rules. Maybe I haven't thought enough about how these 2, 3, 4, 5 sit, because I've just assumed that this can be a 5-3 or a 5-4 pair. But I don't know how to come up with any other idea. I just can't see what else is going on. These two are the same. I mean, that's the other similarity pairing that exists. So they can't be the same as this one, because in this box they're in the same box. And they can't be the same as this one because they're in the same box again. So on this palindrome we have 3 different digits from 6, 7, 8, 9. It just doesn't mean anything, does it? Because actually that's not necessarily true. These 3 could all be the same, I think. So there might only be 2 different high digits on that arm of the galaxy, on that palindrome. Crumbs, I'm not spotting something going on here. What is happening here that I can't see? Just need to think of something that I'm being told. I don't think this is a set theory puzzle. Really don't. I just don't think anything else can be happening that's so brutal. Is there another digit that has to be up here? No, because we just don't know enough. Right, one of these is a 7. How's that helping? So if that was a 7, we'd have a 7 in one of these 2 cells. Therefore, a 7 in one of those 2 cells. Don't see what that does for man or beast. Okay, well, this is a 6-9 pair, so that's a 6-9 pair. Is that telling me anything? It really isn't. I mean, I know that one of these is 6-6, one of these is 9-9. The one that's 9-9 gets an 8 and a 7 here, so 9-7 form a pair, 9-8 form a pair in one of these, and 9-6 in the other. just can't see what's interesting. Those two are the same. Could be the same as that. They would go blue. Crumbs, I'm sorry about this. This is painful, isn't it? What can we do? There must be something that lets us take a step forwards. It's not ones. I mean, 1 in this box can be in any of those cells, any of those, any of those. I can't see how to rule it out of any of those. And then we know it's in one of those two. Oh, it can't be on the diagonal. That's totally uninteresting, but it is true. If it was there, these would be consecutive digits, which, if they were high, would mean... No, it wouldn't mean that they couldn't be from 5, 6, 7, 8, and 9. And I mean, I don't know why that would help, even if it would mean that. And it doesn't. Oh, crumbs. Crumbs. So one of these is a 6. Whichever one is a 6. Okay, if that's a 6, that's a 6. Because then this isn't the 9, 9 pair. So then, then that can't be a 6. So this can never be a 6. Oh, that's simple enough. Well, I mean, it's not going to advance us much, but I don't think either of these cells can ever be a 6, because one of these two has to be a 6. And that means, how do you see this? Whichever one of those is a 6. So if that was a 6, then this has to be 6. I thought I could see this a moment ago. Yes. Yes, it's because blue, yes, if that's a 6, that's a 6. And then neither of these two can be 6. That's the simple way of looking at it. And if that's a 6, that's a 6. And neither of these two can be 6. But one of them must be 6 because there is a 5 here. Right, so those two can't be 6. So now 6 is on the diagonal in one of those two spots. And that can't be 6. And that feels like it's something. I don't know that it's very helpful. But these can't then be 5. Oh, I don't know that one's there. It might be or it might not. Do I know any more about 6? Or, yeah, these two. Trouble is, it doesn't apply to anything else not being on those cells. So these two are the same. So if they were 7, this would have to be 7 down here. And indeed, that would have to be 7, because one of those two is 7. So then you couldn't have a 7 on this purple palindrome. Now, I don't know what it means. Do not know. Keep coming back to this and going, I bet it's not 5, but that would put 6, 7, 8, 9 in all of these cells. Wow. That would put 2, 3, 4 down here on the diagonal. And that would mean this was a 1. Now, can they be from 6, 7, 8, 9 if that's low? I don't think there's a problem with it. It does look quite constrained. Oh, this cell would be the same. Ah, this cell is the same. So that's ruling out whatever is in it from these. So if these are a 6, then 6, then 6 would have to be on the arrow. If these are a 9, then 9's going to have to be on the diagonal. Well, that's interesting. So 9 is either on the diagonal or that's a 7. Ruling either 9 or 7 out of those and putting it in there. It's sort of interesting. We're sort of getting somewhere thinking about that. So that's if these two are the same. What about down here? Those two are the same, so can't be in these cells. So somewhere in these we get a 6 or a 9, and that's definite. And if it's a 6, it's not on the diagonal. It would have to be in one of those. Wow, I mean there's huge steps to be made if we can get through the next part of the puzzle, whatever it is. But I don't think I'm on the right track quite. I'm looking at these being the same. What about these being the same? Come on, is that doing something else? It's putting this, oh, I've got these reduced as not having a 6, of course. So those two can't have a 6 because they're the same. So in one case, either that set or that set is a 7, 8, 9 triple because only one of them can have a 6 in to break that up. Come on, what does that do? I don't know. These two being the same. So let's think again about whichever one of these has a 9 in. If it's here, no, whichever one has a 6 in is the one that allows this thermo to be 7, 8, 9. So 6 there means this would be a 7, 6, 9 triple. And what would that mean up here with 7, 6 and 9 having to go in this area? Not much. Oh no, if this was a 7, 6, 9, that would also be a 6. So then we'd get 1, 6 here, 7 here, 9 here. Wow, then this would be a 6, 8 pair. You'd have used 6, 7, 8, 9 on the diagonal before coming down here at all again. So that begins to make it look like these have to be low numbers, but I'm still just not sure. That's if this was a 6 pair, which is when we have 7, 8, 9 here. If that's a 9, 8 and 7 are there. So this has become a 9, 8 pair with a 9 here, putting 9 on the diagonal. Then this would have to be 8 or 9 because you couldn't put 9. You could put 9 here, but if you didn't put 9 here, you'd be putting it here. And then this is going to have to be, there's going to have to be an 8 here, and it can't be on the arrow anymore, so it would be here. So in the case of this being 9, that's 8 or 9. In the case of it being 6, then we've got 1, 6 here, and that's a 7. So that's not a 5. That is 7, 8 or 9, which is beginning to form 3 parts of a quadruple with this on the diagonal. And I have a feeling the 4th part is going to be up here as well. Oh, that's interesting. This can't be a 7. Ah, right. This can't be a 7 because that would be an 8. Where this is an 8, it's got a 7 here. So you'd now have 7s in these positions. 7 in the central box would now have to be here, given the diagonal. No, this isn't what I saw a moment ago. It's to do with 7 down here. 7 would be there. Hang on, I just saw this a moment ago. If 7 was here, that would be 8 on a 7, 8, 9 triple. How can I not see this again now? Or did I see it the wrong way around? If that's a 7, 8, 9 triple, that's a 7. Those two will become 7. We'll have 7s in these positions. And maybe that can work. Oh, bother. Oh, no. This was it. This was it. If this is a 7, we've got 8 here, 9, 7, 6 on these cells. I saw this. I saw that a 7 doesn't work. Come on, think about it. What did I notice? Seven there, put 7 in all of these places and there. Maybe it can work. Maybe I was just misled by my own foolish brain. Oh, well, hang on. 8 here doesn't work. 8 doesn't work because that puts 7 here. Which goes with an 8 here. So you'd get 8s in those positions, 8 there. You're not allowed 8 on the diagonal. Yes, 8 doesn't work. Right, 8 there would force this to be a 7. Now that makes that an 8. It will also make that an 8, because they can't both be 9s, remember. And then you're going to need to put an 8, not on the diagonal in column 6, going to have to be there, but that makes that an 8 on the palindrome, and that clashes with that. Wow, complicated, but that's not an 8. That is now 7 or 9, which I sort of came up with once ages ago. So these are 1 and 6 or 1 and 8 up here. Now, what then? If they were 1 and 8, this would be 9. I don't know. And maybe this not being an 8 had ramifications here. So is it impossible for this to be? No, the clash was only because of those two cells. So this could still be an 8. This is very complicated. What a galaxy. What an extraordinary puzzle. Okay, let's try this again. What am I missing now? One of these is a 5, so one of these is a 6. I keep saying this again and again. So we've got a sort of skewed X-wing on 6s. Well, and in fact a triple. Sixes can only be in those positions in rows 4, 5 and 6. Is that interesting? Well, it means there definitely is a 6 in one of these two, because there are only 3 boxes for those. Okay, so there is a 6 in one of those, so none of these is a 6. So if there isn't a 6 here, there's a 6 here. at which point we get 9, 8, 7, 5. 4, 3, 2. 3, 2 here means 4, 5 here. Oh, this is how simple it is. Good grief. I'm sorry I couldn't see this. This can't be a 4, because then this thermo goes 4, 3, 2, and they all see that cell, which has to be one of them. So that's not, it's a stacking problem. Good grief. So that's not a 4. So now this isn't a 5. The same's true here. 4, 3, 2 there would make that cell impossible. So that's not a 4. That's not a 5. Now we do have a 6, 7 pair here. Now we've got a 6, 7, 8, 9 quad in both of these positions. And 6 is definitely in one of those two cells. And definitely in one of these two. None of these can be 6. It can't be on the diagonal because we know one of those two is 6. So it must be in these two cells. And that is a 1, 6 pair. And we do get a 7 in this planet up here. And now we can disambiguate these. 8 there, 9, 6, 7. 9, 7, 8, 6. And those quads are done. Wow, this is where 6 is in the central box. This is a 9 now, and that's on the palindrome. That makes the, oh, that 6 is on the palindrome, that 9's on the palindrome. These are 7 and 8, but that's on the diagonal, so that's 8. That's 7 in blue, 7 in blue. So the palindromes are fully done. Wow, okay, and this is a 5. So this isn't 5, so this is, and that's 6. Let's get rid of the 5 markings. So this 2, 3, 4 triple, does that unwind or does it? It doesn't unwind. I curse your eyes. Right, 2, 3, 4, 5. That's not a 5, that's not a 2. 9, no, 7, 8, 1, 6. 9 is up here somewhere. Can it be on the diagonal? Probably. Haven't discovered about these ones. Now look, 6, 9 as a pair ruled out of all of those. So 6 and 9 have to be in this group of cells. So one of them could be here, but if one of them wasn't there, they can't both be here. So you'd have to have the larger one here, 9, and this would be a 6, 3 pair, which would make this the 1. So this is either 1, 6 or 9 in this cell. That's slightly complicated, but it is, oh look, 7. There's much more simple Sudoku to do. 7 there, 7 here. 7 can't be there on the diagonal, so all the 7s are suddenly finished. Right. Maybe there's more stuff like that. 5, 5, 5. Come on, keep working. Nothing else from that. But the lesson is, look for the simple Sudoku moves. Rather than the complicated diagonal stuff. Oh, 6 can't be on this diagonal. So it would have to be 9, 3, 6, unless that is 6 or 9. And if that's 6 or 9, this is a 1. Ah, I don't think you can have 9. If that's a 1, these two are consecutive, but would have to contain a 9 or 6. They can't have a 6 for the diagonal, and they can't have a 9 because the other one would be an 8, and that's not allowed. Okay, let me just check that through again. If this was where the 1 is, these two are consecutive. You can put 6 or 9 there, but the other one has to be on this arrow. 6 can't, on this diagonal. 6 can't be on it, it's not allowed. 9 can't be on it because 8 would have to be on it with that 1 there. So this is not where the 1 is. The 1 is here. And now 9 and 6 do appear here. They can't both be on the arrow, so 1 must be in the circle. It's got to be the bigger one. This is now a 6, 3 pair. And we know that 6 is not on the diagonal. Wow! Wow, 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 wow. So we get an 8 in one of these two cells. I must have done more than this. 9, 6 pair, 9, 6 pair. We get a 9, 6 pair here. But we've got 9 in one of those two cells, so that sorts out the order, 9, 6. That sorts out 1, 6 up there. The remaining ones in columns 4 and 6 are a little X-wing. And, there's a 1 here, and therefore a 1 here. So they're done in rows 4 and 6. These are from 2, 3, 4. 8's in one of those 2 cells. Still haven't sorted out that arrow. That's almost the last clue. This can't be a 4 because it's on the thermo below another 2, 3, or 4. So now there's a 4 here. It's a bit odd that these aren't resolved. If they aren't meant to be, then bother. Right, 6, 7, 5, 9, 1, 3's in one of those 2 cells. That's not. Let's have a look at the diagonal. 7, 8, 1, 6, 9, 3. So we've got 2, 4, and 5 to place. Oh yes, the 9 on the diagonal fixes this to not be a 9. So we get the 9 there. There's the last 9 in the grid. So that's all the 9's done. Now, 2, 3, 4, 5. So 8 goes here. It's the only place left for it. That gives us 8 here. We've got an 8 there. There's going to be an 8 in one of those 2. And somewhere in those 3 rats. So now just small digits largely to do. Oh no, look, that's not an 8. So we've fixed the 8 there. And that fixes 8 down here. So now we're going to be down to small digits. We seem to have done 9, 8, 7, 6 in pretty much every box. There we go. No, 8 here, yes. Now we have done 9, 8, 7, 6 in every box. Right, 3 there. So there's a 3 in one of these 2. 3 in one of these 2. 2, 3, 4 here. 2 must be, oh, that can't be 3. 2 must be in one of those 2 for the row, so that's not a 2. Come on, keep going. We're nearly there now. That can't be a 5 because it's C's a 5. Whatever those 2 are here. Not interesting. These are from 2, 4, 5. 3 is over here. One of those is a 4, so that's 2 or 3. Is this actually still going to unwind? It's going to all come down to that, isn't it? If those 2 add up to 7 out of 2, 3, 4, 5, then those 2 add up to 7 as well. Yes, okay, the other way to look at that is the only place for a 3 in the box is in one of those 2 cells. So they must be a 3, 4 pair. That's very clever. So we get 2, 5, 4 on the diagonal. The diagonal's finished. 3 there. 2, 4 pair gives us 3 there. Thermo gives us 2, 4 there. This is 2. No 2 there. So now we've got a 3, 4 pair here. So that gives me a 2, 5 pair, and I can fill in 3 and 4 down there. This can't be a 5 anymore or a 4, so that's a 3. That's a 5. That fixes 2 and 5. This is now a 2, and there's a 5. This is 2. This 4, 2 pair's been done. That 4, 3 pair hasn't, but it is now. 4 done there. 3, 4, 3, 4. This is a 5. This is a 3. 1 and 5 here. Yes, they're done. 2 and 4 at the top. Can't do them, but I can do 2 and 3 down here. I was going to say, how is that 2 and 5? It's not. 4 and 1. And there we go. That is the finish of the Spiral Galaxy. Just over 40 minutes. What a brilliant puzzle by Malrog. That's amazing. I know I made some heavy weather of getting to the stage where these were 6, 7, 8, 9 quads, but it wasn't easy to see. I don't think it was. Yeah, it was all to do with these being the same Oh, it was tough. It was tough. I wouldn't want to go through that again. That was entertaining, though. It was certainly not warp speed through the galaxy, but it was great fun and brilliant puzzle. Thank you very much to Malrog. And thank you to you for watching, as always. Hope if you had a go at that puzzle, I hope you did well with it. Thank you, and hope to see you again soon. Bye for now.